IMSA fans, we are here at technical inspection where all of the work before the game happens to make sure all the players are legal and compliant. We have our friend Matt Kurdock, who overlooks so many things from IMSA's technical department. One of them, which is really cool, here, tech inspection, there's some sort of magical 3D wand going on behind us here. Tell us about this magical device, Matt, what it's being used for up on the scissor lift. Here we have a beautiful BMW M Hybrid V8 GTP car. What are you guys doing with that wand?
So what we're doing is we're collecting laser scanning data of the bodywork surface to make sure that it's in compliant with the three-dimensional surfaces that each manufacturer has provided IMSA as part of the homologation process. It's the same process we use to go through our wind shear program at the wind tunnel, where we're just making sure that the bodywork surfaces are within the prescribed regulation tolerances to these 3D models. So we've integrated it in the GTP inspection process. Every car has got to go through this process multiple times throughout our race events, and we're not able to, in a regular tech inspection process, do a full scan of the car. So you'll see that we focus on areas of higher aerodynamic sensitivity than others. So when we go through the efforts of the wind tunnel homologation process, that's where we capture all of our baseline aerodynamic data for the GTP cars. And for us to be able to reference any of the track data we're collecting, we need to understand where the car is relative to that baseline data from wind shear. We're also making sure that the shape of the car and the shape of the surfaces are within the tolerances prescribed by the regulations. On the top side of the car, we have mainly 3mm tolerances that the entire car needs to conform to. On the bottom side of the car, on the floor, where it's really sensitive, we have between 1 and 2mm tolerances that we're asking these teams with 5mm or 5 meter long cars to hit that tolerance.
It's a tiny amount.
So it's a very small amount. The scanning technology we're using here is accurate down to 25 microns, so about half a human hair.
Wow! So,
and we're able to do that over a very large range of a very large volumetric space, so conforming to basically the shape of the car. So the very high precision instrument that we're able to use in a variety of ambient conditions, which is important when we're doing inspection outdoors like we are. So there's two main elements. So one is we have a tracking camera system here. So two cameras that are watching a variety of targets. You'll note that we apply targets, reflective targets to the cars before they
certain points of the body.
At a certain point. And then also the scanning wand also has the same targets on it. And so this camera system is tracking in 3D space where the car is and where the scanning element, scanning wand is as well. And then on the scanning wand, we have a laser target system that's got that can paint 15 different laser stripes, and then tracking sensors here to look at the reflective data coming back from the bodywork, and from there we're able to see the position of the surfaces relative to the 3D space. And we're able to, because of this system, we're able to pivot it around the car. We're able to raise the car up and down on the lift, and then not have to recalibrate everything to certain datums.
That's really smart.
Underneath the car is, on all the GTP cars, we have 4 chassis datums. 3 of them are machined into the survival cell, and 1 is on the gearbox. And our guys will take spherical targets and we'll thread them in to those chassis datums. And all of the scan data we get on this system is aligned to the CAD model through those chassis data.
Computer-aided design models of the car.
Yeah, so it allows us to do a precision alignment of this scan data collected in space to a CAD model. And then from there, we have a sophisticated piece of software that will compare this cloud of scan data to the regulatory surfaces. And what we'll get is we'll get a CAD view of the car that's now got colors applied to it, and the colors indicate how far in or out of the model the surfaces are. So, like for example, we may have some surfaces if the surfaces are all on the regulatory surface, they're all green. If they're higher than the surface, they could be red. If they're lower than the surface, they could be blue. So that allows our tech officials to go through and characterize where we have different tolerances on the car, whether or not the cars are meeting those tolerances. So, for example, the diffuser strakes need to be within 1 millimeter of the model. Wow. The diffuser needs to be within 2 millimeter. The splitter needs to be within 2 millimeter, and the top of the car needs to be within 3 millimeters. So it's a very complicated process that we introduced with the introduction of the GTP platform, but it allows us to do things that historically we would need a whole bunch of manual gauges and hours to go through and to even get a snapshot of what we can do with a 30-minute inspection now with this system.
No more hammers and duct tape, Matt.
That's right.
Make sure you follow along with us on IMSA's official YouTube channel and follow IMSA Racing on Instagram, Facebook, TikTok, and X. We're going to be doing some pretty cool stuff with some pretty cool people with some pretty cool race cars. Visit IMSA.com to hear the action called live and download the official IMSA app to follow the timing and scoring information as the sessions take place.